So thermodynamics is the study of how energy transfers from one form to another. We can think about thermodynamics for a physical process, for a chemical reaction, and we are going to incorporate ideas from back in chapter 5, which includes enthalpy, which I think is the one thing we covered in chapter 5. So we have talked a little bit about enthalpy this semester as well. That's going to come into play yet again. So just a brief reminder of the first law of thermodynamics. The first law says that energy is conserved, it can't be created or destroyed. We can transfer energy, but the total value of the energy remains constant. The ways we can transfer energy are by heat or by work. So we have probably you've seen an piston example 100 times. You can imagine that heat is given off by a reaction, or that by a reaction it forces a piston to lift, and that is work done by a system. Okay. We talked about exothermic versus endothermic. Chemical reaction that gives off heat is exothermic. Something that absorbs heat is endothermic. And you may also want to recall how we can calculate enthalpy for a reaction. There's a couple of things here. Let's see. So enthalpy is the heat involved in a chemical reaction. Rxn for reaction. Q is heat, is equal to delta H. It's basically just saying that the change in heat is equal, or the change in enthalpy is equal to the heat. Or the heat is equal to the change in enthalpy. Let me check this here. Okay, yeah. So for a given reaction, we can determine the enthalpy by this equation. Delta H for a reaction is equal to the sum of the moles times the delta H of formation of the products. You guys remember this? Minus the sum of the moles times delta H of formation of the reactants. Okay. Delta H of formations are values you can find in a table. Okay. So if we have a reaction such as this, where we have methane plus chlorine forming carbon tetrachloride and HCl, we can look up the delta H of formation for each of these species and calculate delta H for the given reaction. Okay. And recall with our delta H values that elements or species in their elemental form, such as Cl2 and O2, delta H is going to be 0. Okay. So for this reaction, if we want to actually calculate this, delta H of the reaction is going to be equal to, we'll take our carbon tetrachloride, there's 1 mole of that, that's the stoichiometry, that's the stoichiometric coefficient, times its delta H of formation, which is minus 135.4. And this is kilojoules per mole. I'm going to leave off the units in my equation though. Plus 4 for the HCl times minus 92.3 kilojoules per mole. We'll multiply and sum all of that, and then subtract what we have for the reactants. So we have 1 mole of methane, times its delta H of formation, which is minus 74.9. And just for the sake of showing this, we'll have 4 times the chlorine, which has 0 kilojoules per mole. And so when we do all of our algebra here, we'll end up with a delta H for the reaction of minus 429.7 kilojoules. And it's in kilojoules, not kilojoules per mole, because we've multiplied by moles for each of the values of delta H. Make sense? So is that endothermic or exothermic? Exothermic, right. Does this topic feel familiar? Do you remember how to do things like this? Vaguely? Okay. So let's think a little bit about spontaneous processes. A spontaneous process or a spontaneous reaction is one that occurs without any outside help in terms of heat or force or anything like that. The reverse of a spontaneous process, get this, non-spontaneous process. I'm going to spend the time to write that down. Okay. One of the interesting things, though, about spontaneous processes is that they can be either really fast or they can be really slow. The spontaneity does not tell you anything about the rate of the reaction. Let's see. For a non-spontaneous process, we need energy to make it happen. So we'll need to add energy to the system in some way. Spontaneous process can be fast or slow. Spontaneity doesn't tell us about rate. So other terms that you're going to, or another way of stating this, is if we can determine if a reaction proceeds in the direction written, that's saying the same thing as saying, is a reaction spontaneous? So determine if a reaction occurs in the direction written, which means it goes from reactants to products, okay? Another way, it's just another way of saying, is a reaction spontaneous? Because if you imagine having a reaction that occurs spontaneously, it goes from reactants to products. If we reverse that reaction, the reverse reaction is non-spontaneous. So we would have to put some sort of energy into the reverse process in order to make it happen. This is the way batteries work. We're going to spend a little bit of time talking about batteries. Right? So the battery works by spontaneously giving off electrons to run some sort of device. When you charge it, you're forcing that reverse reaction to go, or you're forcing the reaction to go in the reverse direction. So if you charge a battery, that's effectively what you're doing. That's Sean Connery. This is from the movie 007, Diamonds Are Forever. The reason I include this slide here is because the formation of graphite from a diamond is a spontaneous process. But it's incredibly slow. Okay, so it'll take many, many, many years, millions of years, to go from a diamond to graphite. So, as I mentioned, if we say in which direction does a reaction occur, or is a reaction spontaneous, we can't use enthalpy to help us figure out if a reaction occurs or if it's spontaneous. We need the second law of thermodynamics, which is a consideration of entropy. So the second law of thermodynamics says that the total entropy of a system and its surroundings always increases for a spontaneous reaction. Okay? And we often think about entropy as a measurement of how dispersed energy is, or a measure of disorder. It's a common way of thinking about it. a system that has energy dispersed in many ways has greater entropy than something that only has energy in a few ways. So if we think about a solid versus a gas, think about particles in a solid, they can only be in certain locations and move around very, very little. Where if we have a gas, particles move around quickly and through space, can be in many more places, so a gas is going to have greater entropy than a solid. And when we're thinking about the entropy of the system and the surroundings, I like thinking about a cup of coffee or tea. You put hot coffee into a cup, that the heat starts to warm up the mug. If you're holding the mug, it starts to warm up your hands. Maybe you put it on the table, it starts to warm up the table. And now that energy has dispersed to many different things as opposed to just it being in the coffee. Okay? So that the process of a solution cooling is a spontaneous process. Okay? Things don't spontaneously heat up. Some other great examples of spontaneous processes are iron oxidation, or the formation of rust. Again, heat flowing from hot to cold, or a rock rolling down a hill. And my favorite spontaneous process, spontaneous human combustion. All right. I think we'll just end on that. Question, yes?
So the homework that's due Monday, is that pushed back?
Let me check what's all in the one that is currently due for Monday. I think I have 2 sets due Monday. So I'll go and check that next and set everything where it should be. Have a great weekend, everyone. Yeah.
Not related to course material.
Okay.
Do you know how the makeup exam exemptions work at all? Because I posted one. I'm gonna be out of town. My grandparents, they have a house in, God, I forget what it's called. Wherever the hurricane hit really bad.
Okay.
So I'm going down there to help like fix their house, you
Yeah.
know, because they're old. But I don't know if that's like enough to get the exemption. Like,
I honestly don't know. Like that example, I'm sure has never come across the table. Yeah, I don't.
yeah, because I made we got the plane tickets like when the hurricane first hit, so I didn't really think about it. And it sucks that they don't tell you until a week before the exam, because then I can't really cancel it.
Oh yeah. When did the hurricane hit?
Like a month or two.
It was during the semester, right?
Yeah.
I think that's working against you
Okay.
because the exam dates were published.
Yeah.
So you might have to do the makeup at the end of the term, which actually won't be that much
Oh
later.
wait, so even if I do miss it, I can still do it at the end
Yeah,
of the
that's
term,
the
and it
other-
won't affect my grade.
Correct.
I see.
Yeah.
I just can't do it like
That week. Yep.
Interesting. Okay. Awesome. Thank you.
Yep.
I have a question.
Uh-huh.
So I truly remember before that I didn't have as low of a grade as I did. Like, is there a way to check what it was before that was added, or because I remember like waking up Saturday morning, seeing it, and I was like, I thought it wasn't good, but it was better than I thought I did. It was like a low 50, I believe.
Okay.
I don't have any screenshots. I was like searching all throughout my phone. And now it says that without the point added, it would have been a 39%, which I know that I did not, because I would have had
Yeah.
I would have remembered if I got a 39% that morning. And I'm just like very confused on like what went wrong.
Yeah.
Like, I don't,
What's your name?
Holly Harenza. Harenza.
Okay.
Like,
I can take a look. I might
Yeah.
be able to see which has changed. I may not,
yeah,
but I will.
I'm just like very confused. Like, I know I looked at the right midterm
Yeah.
and everything.
Yeah.
It's just that I don't know. Like, I knew it dropped my grade a lot, but like I would have like remembered if I got a 39% without that added.
That's more memorable than
Yeah.
the 50. Yeah.
Yeah, so that's why.
Okay.
Okay, thank you so
Yeah,
much.
I'll take a
I was
look.
just wondering if there was any way to do it because I was very confused.
Yeah.
Like, could there something like? Is it possible that something was messed up, or am I like just creating things in my head? Like, I don't know. It would be disappointing if it is, but
Who knows?
Okay.
I didn't know even that they were giving a point back until that announcement came out. I didn't know
Yeah.
what question it was.
Yeah.
So I think I can see the history of changes.
yeah.
And if that's the case, I can figure it out.
Okay.
If I can't, then I'll have to.
I
can
mean, we were
maybe-
adding it up. It's not like it was saying the wrong thing. Like it literally said like 12 out of 28, but I was like, I do not remember that. Like,
Yeah. Okay.
okay, thank you so
Yep.
much.
How's it going?
Yeah, pretty good. Okay, so I have a question about the complex ion.
Yeah.
Well,